So the basic way that light works so it travels in a straight line, right? So if you've got a light source, right? We've got a circle to represent our light source, right? I'm going to put a dot in the center. This is where I'm going to draw lines out from, okay? To represent the direction of light. So the way light works, it's traveling from a finite point, it's traveling from a single point, basically, right? Outward in all directions. That means it is hitting every direction. It is hitting every direction in a 360-degree coverage, right? So like, this is something that you physically can't do on paper, actually. So we're gonna do it badly. So we've got start making lines, right? And it doesn't matter about distance from each other because we're supposed to cover every direction, right? We're supposed to cover every direction. Point is, you can do this forever, and well, maybe you can physically do it on paper. Point is, you're going to eventually cover all of this, right? And it's just being done with straight lines, right? People don't understand what you can still do with a straight line. You know what I mean? Because like, if this is your light source and these are the holes, light is chaos and it fills the gap. So whatever size hole you give the light to go through, that's usually the size, that's usually what's coming out. It's going to make the 2, see here's the 2 originally, right? Because it's slightly bigger than the center, the 1 millimeter centerpiece. It's 1.5. So you get a quarter on each side, right? So you get a 1/4 millimeter on each side, right? And then you get general ambience, as well as the fact that whatever median that they are putting, this is reflecting light also. Everything reflects light. That means that when the light goes through here, when it hits the edge of the paper here that you can't measure because it's less than it's like 1/4 of a millimeter. It's like 1/4 of a millimeter or less, probably. So there's distance there, right? That means there's distance there. That means a few of these would make 1 millimeter, right? A handful of these would make 1 millimeter, right? So there's distance. The paper has distance here. So when it goes through the hole, it's hitting the paper as well. Or whatever they're using in the videos, why they're using reflective things in the video is beyond me. And have you ever noticed that they all look the same? Have you ever noticed that whenever you look up the double slit experiments, wherever it hits on the wall or whatever surface they're using, it always looks like this. I cannot get this result, by the way. I just cannot repeat this same thing. I cannot get what they get. It just looks like there will be like the initial one that's like bright, and then it's kind of like spread out like that, like it's got, right? And then there will be like and then there will be other ones spread out like this, right? It'll make like a kind of like a dotted line pattern, right? Uh, or a perforated line type of pattern, right? Like that. I cannot get this effect. I cannot get this. I keep trying to recreate it. When I shine it through here, it kind of just scatters and makes a bunch of really crazy patterns. When I do it with the flashlight, I showed you with the flashlight. I'll show a better video of it with the laser when I've got the light off. You see, we've got the two, but you can move it and it starts creating weird patterns, right? You can see the glow around it as well as, you know what I mean? It's not only is it just not a clean experiment, but the claim is absurd for just shining light on a wall. Plus, we're talking about a hole that is. We're talking about a hole that is like a size of a building compared to the size of like a photon, a photon particle, like we're just talking about a dot compared to. Hold on.